once your company is more established, like what I mentioned earlier, you will start to build models. You have recommendation models, and you have other different types of models to do prediction and forecasting. This is when a machine learning engineer comes in.
Welcome to Data Crunch. Now, every now and then we switch up our episodes a little bit, and in this episode, we're going to answer a question asked by someone who sent us an email. So the question is here. Although I attended some of your free events, such as the Data Science Uncut Bootcamp Demo Day, I am more curious about how are some of your students applying the tools they have learned to their current workplace. On the demo day, this is referring to Data Science Uncut Bootcamp, I saw that the data used by the students were all existing, meaning that they get this data from a data source somewhere. The data set is ready. How should the real data be imported and calculated? If a company does not want to allow data leakage as an excuse using cloud, is only willing to invest in computer and server equipment to do computing? So the question is, do our students have the ability to build systems? So there's a few questions here. Dr. Lau, you want to take this from the top?
Sure. So let's start from the very beginning about data collection. Again, I would like to say, right, data science is about cooking. So even if you know what dish to cook, you still have to know how to collect, where to buy those ingredients. And same as collecting data. And there are two types of scenarios that I usually encounter in my career, in my job, is that either the company has a lot of data sitting there and they don't know what to do with it, or they don't know where to start collecting data. So let's start with the first one. It happens very often in big corporations or MNCs, right? They bought a lot of systems. You got HR systems, finance systems, you got inventory systems, and then those systems generates a lot of data, but they don't know how to put it into good use. So they left a lot of valuable assets just sitting there in different silos. On the other hand, you have newer companies, smaller companies, startup companies that don't know how to get started to collect the data. And there are actually many ways to collect data in today's world compared to 20 years ago when I started doing data analysis. You can get those data from just by running a survey, just direct. Go direct and ask your customers, like, how do you think about the product? What are the things that you, on the services that you think we should improve? And then the second way is go around and do some competitive intelligence. Just build a scraper, or what they usually call a crawling board, to scrape people's website. You can scrape from social media sites. You can scrape from product review sites. You can scrape from news site even. So these are some of the ways of you can think creatively out of box, right? And to gather data and start your data analysis journey.
So I think the perception of getting data is that a lot of people think that they have to get a lot of data, like big data, right, before they can do any sort of analysis. But in your experience, right, for a given medium-sized business, what is the amount of data that is required before they can start doing any type of analytics?
I think this question has started to become a theme that we should do a separate episode to talk about this. It's a marginal effect that whether you need 10,000 records, 50,000 records, or 1 million records in order to build your data science or machine learning models. And the key here is, if the quality of the data is good, it has a good mix and it has very little bias and is able to represent the entire situation pretty well. So, which means in layman's term, when you are building your model and when also the accuracy is good, and then when you take it to the production, it does not fluctuate too much. And this, I would say, it has a good fit and you have a reasonable amount of good data. So it really depends on your industry, your customers, and that's okay. So let's say if you are in e-commerce, you are trying to analyze the behavior of your customers, right? You probably need a lot more data, like at least half of it that should be very representative. So if you have 1 million transactions, and I would say at least 30%, 40% of those transactions needs to be very representative and have a good mix. And if you are building something like the image recognition or driverless car, you need even more training data. You need 10 million images, 20 million images. And if you remember CAPTCHA, like Google is still collecting images and asking us to do the labeling for them. So the key here is that there's no one fixed numbers that I can tell you, like, okay, you just need 10,000 data to start with, or you just need 1,000 data. Because in when we are teaching, right, the HR example, HR usually you can't find that many companies that have more than thousands of employees. So um, when you are in a more static situations like human resource, right, then you don't need that many training data. You can use the entire training data set, and that's only like 200, 300 records even.
That's very interesting because, with the new Google Analytics number 4, they have also gone to the same thing where they use machine learning to guess the parts of the customer journey points that cannot be tracked or analyzed. I mean, it cannot be tracked from the software itself. So they use machine learning to kind of like guess where these users are going and what they are doing, right? And there's this setting where you can change the time length, the time frame of the machine learning algorithm within a few days to 2 weeks or so. And when you change it to 2 weeks or so, it becomes more accurate that way. So I will suppose that with higher length of training, it takes in more data from the analysis as well. So that makes it more accurate as well. Speaking about e-commerce stores, let's just dumb it down to an e-commerce store. So let's just say I'm an e-commerce store today. What are some ways I can use to import or collect data, to obtain data if I were to use the first framework from the OSEMN framework?
So when you run an e-commerce store, you usually have an e-commerce systems or platform in place like Shopify, WooCommerce, and these systems allow you to export your orders and your customers' details to a CSV file, Excel file, and that's actually a very good place to start with because number one, the data is up to date and the data is pretty clean, and number two is the data is good, is well structured. So you don't have to do too much of the guessing work or analysis work unless your e-commerce system is not properly set up, which usually would be the case. And once you get that right, you can use that to do a lot of things. Number one, you can do product analysis. You can look at the common ones, like which one is the best selling product, which one is the worst selling product, and you can look at the customer's behavior. Now, this is the interesting part. And since Ruben mentioned about Google Analytics, and we continue from the previous question, what we want to see is the model improve along the way when we have more data. So let's say when you just started, you have only 50 transactions to analyze. That's absolutely fine. You look at one way that you can look at it is to use RFM score. You look at the recency, you look at the frequency, and you look at the money. When was the last time that this customer came to your store? When was how much they spent when they visited us, and how often they visit us? Right? And this is for us to identify loyal customers, good customers, or sleeping customers. And another way that we can do it combined with Google Analytics, which is like to check what are the products that people often view but they did not buy, right? In digital marketing sense, I think it's the click-through rate. So what are the products that a lot of people click? They spend a reasonable amount of time. Like they spend 2-3 minutes browsing it, and then they did not buy. They did not click the buy now button. And I think Ruben knows that because they did not convert, and usually it's because the price is not not it's not a good price for them, I would say, right? So they don't like the price, or sometimes it's after they read the descriptions and they found that this product doesn't really suit me. So you might want to fix the copy a little bit. So I think I have given some of the good examples that we always use in e-commerce. And if you want some more advanced use case, then you can look at product recommendations using association rule mining. So for example, what are the items that people often bought together? Is that chicken, is that bread and butter, or is that bread and eggs, or is that milk and peanut butter, right? And once you have identified these items, you can do a cross-sell, you can do an upsell, or you can even bundle them together in a package and say, this is your champion for breakfast for champion package, which we sell peanut butter, bread, and eggs together. And these are very common and proven techniques that we use in e-commerce.
All right, that's a very good explanation of that, Dr. Lau. Let's talk about the roles of data science within the whole industry, right? So there's data scientists, there's data engineering. So I understand that building systems to collect data, this is something that is probably not a role that is done by data scientists. Or what role is this? I mean, who does this sort of processes?
So we come back to the student's question earlier, right? He was under the impression that in the data science team, usually the data scientist has to be the one that does everything. So they need to be in charge of collecting data. They need to be in charge of cleaning the data, building the models, and then present it, which is true, right? At the beginning, or even in a team setting, the data scientist is usually the one that look after the entire process from end to end. But actually, in a data science team, another we have three other roles, which is data engineers, data analysts, and also machine learning engineers. Data analyst's job is to analyze the data, as the name tells you. But what is more important is that they will look at the existing data, the data that's already there, and help us to uncover insights that you might have missed from looking at the data. Usually, when people look at data, they look at the obvious thing, right? They look at the trends, the patterns. But what data analysts should do is to state the non-obvious. They should look at how come some of the data that should appear, but they did not. Or you launch a marketing campaign, your sales should go up, but it does not. And what are the reasons behind? And this is what the data analysts will do and help the companies to find out. And we also have data engineers. Data engineers' job is to make sure that your data platform is running well. You are collecting data, you are storing data, and you are also allowing people to consume the data. And more importantly, you're allowing only the right people to consume the data. We used to call it data warehouse, right? You don't want to open your warehouse like an open house to everybody who can come in and browse and take whatever they want. So you want to allow certain people that, okay, data scientist is allowed to access this part of the data, finance people is allowed to access this part of the data, and then HR, sales and marketing team has access to different parts of the data. So this is the job of a data engineer. And once your company is more established, like what I mentioned earlier, you will start to build models. You have recommendation models and you have other different types of models to do prediction and forecasting. This is when a machine learning engineer comes in. A machine learning engineer's job is to help to make sure that the model is working well and is still relevant to current data that or the future data that we are collecting. And once they identify that our model starts to fail or in a safer way, the performance of the model starts to fluctuate. Then the machine learning engineer's job is to identify which part goes wrong and discuss with data scientists, data engineers, and data analysts to fine-tune the models. If not, we might have to retrain the model from time to time. Yeah, so these are your other teammates in the data science team, and data scientist is not alone. It's a team sport.
Yeah, so from here we understand that the whole data pipeline, right, is handled by a few people throughout the whole. It's not just one person, a data scientist that does the whole end-to-end kind of thing. So you have to also work with multiple people, multiple different roles within the company, and knowing which role suits you better depends on whether what you are more interested on doing. In fact, we have an episode on Data Crunch talking about specifically these sort of roles as well. So we can just put in the link below if you want to check that out as well. Yeah. So let's talk. He raised a good question here, where if the company does not want to allow data leakage, right? So let's talk about that a little bit, right? Now, if a company does not want to share its data to its employees to do some analysis, how do we get a company to have some buy-in into this whole data science thing?
A lot of companies make this mistake when they want to so-called invest into a data journey, right? They want to kickstart data analytics journey. They think that the safest way to protect the data is to keep the data with them, meaning they want to have on-premises servers and they think that storing data in the cloud is not safe because you are storing the data on the internet. But we all know that, right? If you compare storing your data on Google Drive versus saving the data in your own USB flash drive and carry along, which one has a higher risk? You might lose your USB drive, you misplace it, it might get stolen if it's something that's very important. And the USB drive, if you bought some not so good brand, then they will fail, right? They will fail, and also you will risk not doing proper backups. Like I have not seen anybody who bought a USB flash drive. They do 3 sets of backups and one backup. Technically, you should have 3 backups stored in different physical location, meaning one is at your parents' house, one is at your house, and the other in the office, something like that. But when you store your data in Google Drive, they do everything for you, right? They have username and password to protect your data. So if you are not the right owners, you can't see the files. Number two, they do proper backup regularly, right? If you lose a file and then you tell Google and they'll help you to retrieve the last additions, the last revision that you have saved. Yeah. So, and number three is they do their hardware check regularly because they make multiple copies and different physical locations. So even if hard disk 1 fail, they can replace it with a new one and copy the data from hard disk 2 and hard disk 3. There's the probability of 3 hard disks fail at the same time is so low, and you don't have to worry about things get stolen or caught fire. So when a company wants to start their data analytics journey, right, they shouldn't go straight into buying a server or a NAS just to collect the data and keep it there. They should start small with a cloud service, and then from there, you don't give access to everybody, of course, right? You only give access to data analysts or data scientists to kickstart the projects. And we have worked with clients like that before. So it's kind of like an education process that we need to teach them, like, okay, this is how you should do things and what are the benefits behind, rather than, it's not so much about technical. It's actually about the mindset of the people. So once they have switched the mindset and they understand the benefits of using cloud, and then don't forget, you save the cost on hardware and maintenance as well. You don't have to hire an IT guy just to look after your servers, because to keep a server running properly, you need to have a well air-conditioned room as well. You need to keep the temperature low, and you need to have a room just to host that one machine. So after I talk about it, after I mentioned so many things, I think the advantages of using cloud versus on-prem servers are pretty obvious.
Yeah, cloud computing is much more affordable because it allows scalability. It's with the speed of our internet these days, it becomes possible for us to use cloud computing like 100% without having to need a server anymore.
I think we can safely say that in at Lead, right, we do it 100%.
Yeah, and I think a lot of people take for granted when they use cloud computing. I mean, if you use Google Drive, you are essentially using some sort of cloud computing, but we don't think of it that way. We just like, Google Drive is just Google Drive, and yeah, I know. So
Exactly.
a lot of people take for granted that cloud computing is that powerful, and it's really useful when it comes to storing a lot of data from a company itself. Okay, so I think we answered most of the questions from this long question here. Is there anything else that we missed out, Dr. Lau?
For this episode, the key here is about the paradigm shift, the mindset shift when you want to move from a non-analytical to an analytical kind of culture and environment. So I just think that if you're watching this episode and your organization is thinking about transitioning into data-driven decision-making process, don't worry so much. There's no right processes. There's no one-size-fit-all solution. You do things that suit your culture. You do things that suit your organizations, because you have to fix the culture, you have to fix the hardware, and you have to fix the processes and workflow. So don't worry, get started, and you'll get there eventually.
So I hope you enjoyed this little episode of where we answer questions that you ask us. If you have questions, feel free to just email them to us. You can email me at ruben@thelead.io. I'm going to put down my email in this episode down here. Or just drop us a message on our website and we'll take a look at a question and we might make this into an episode. So who knows? So I hope you enjoyed this episode. We'll see you in the next upcoming episode. And with that, thank you so much and till next time. Bye bye for now.